Okay. Good evening, everybody. My name is Steve Baker, like it says. I work here at Ticketmaster. I almost said Liquid Web, but I don't work at Liquid Web anymore. I work here at Ticketmaster now. And tonight I want to talk about code attributes. I assume everyone here already knows all about code attributes. I didn't either about a year ago, so I figured it all out, and now you've got a presentation. So what are code attributes? Code attributes are labels that you can stick on a subroutine in Perl, and they can mean pretty much anything you like. They're just labels. They're processed at compile time, not processed at runtime. I'm sure everyone here knows that that Perl has a compile time and a runtime, and that you can run. Drew doesn't, and that you can run code at either time. And you can consider them metadata for the Perl compiler. So, there is also such a thing as variable attributes. I will not be talking about them tonight. The reason is that the Perl 5.18 manual has this to say about variable attributes: they are not really ready for prime time. So, here's an example. In this case, we've got two subroutines, my sub and my other sub, and my sub has one code attribute, foo, and my other sub has two code attributes, foo and bar. That's basically all there is to code attributes. Any questions? No, there's more. In this case, this particular code isn't going to run because there are no code attributes foo and bar defined anywhere. But I can show you how to make it run, which I'll get to in a minute. Now, Perl itself does not use a lot of code attributes internally. There are a lot of modules use them. Well, not a lot, but some modules use them. But Perl has got 3 built-in ones, I believe. Locked, which hasn't worked since Perl 5.1, had to do with synchronizing threads. Method, all it does is prevent the ambiguous call, like it says here. And then this one's kind of interesting, L value. And what that Oh man, I proofread this and I just realized that subroutine is misspelled. L value lets you assign to a subroutine rather than to a variable. And I'll show you an example of that here. Okay. Here we've got a little class called myClass, and it has inside of it a value, which I have cleverly called value. And when you create a new class, that value gets assigned 0. Down here, I have a member of the class, or our method, value, which I have given the L value attribute. And all it does is you can pass it a value, and it will, of course, set that value inside the class. But because it has the L value attribute, you can not only pass to it, you can also assign to it. As an example of using it here, we instantiate the class, print the value, of course it's going to be 0. Then down here you can assign it a value, which looks kind of weird because you're assigning to a subroutine, and then print it again, and the value should be 42. Let's find out if I'm right. Way down here in the corner, yes, for 0 and 42. That is pretty much it for I could have, but then I would have been assigning to the value itself directly, rather than assigning through the subroutine. That would have been a very poor example of an L value code attribute. But yes, that would have worked too if what you cared about was the assignment. As I said, that's pretty much it for built-in attributes for that Perl uses. If you want to use attributes yourself, you use the attributes pragma, use attributes at the top, and that gets you 2 methods. Get, which gives you a list of attributes for any particular subroutine, and ref type, which is pretty much useless for our purposes since we're only talking about code attributes, and it's always going to return the string code. Now, when you declare a variable, or declare a subroutine with attributes, At compile time, this method is going to run if it's defined. Modify code attributes. It's up to you to define that method and for it to be found and run. That's going to get passed, again, this is going to run at compile time. That's going to get past the package name that we're talking about, the code reference to the code that has this code attribute, or I'm sorry, that has some code attributes attached, and then a list of attributes that were on that subroutine. For example, back in my earlier example, I showed my sub had a foo code attribute. So, this is going to be a reference to that subroutine, and this is going to be a list of attributes. The only thing on that list is going to be foo. Now, the only thing that this method has to do is return a list of attributes that were not handled. So whatever else it does is completely up to you. So what it means to handle an attribute. If I get past a foo attribute and I'm going to do something with the foo attribute in this subroutine, and then I'm going to pass back nothing because I handled the foo attribute. If I were to pass back foo, that would tell the processor here that I didn't handle that attribute. And that was going to cause an error, and it's going to throw an exception, and your program's going to die. Now, again, this one happens at compile time. Now we have fetch code attributes. This is another attribute that you would need to declare yourself. This one happens at runtime, when you call attributes get, which, as I said before, is going to return a list of attributes that are on this particular subroutine. And it's going to get past the package name, the code reference, and it's going to return, as I said, a list of attributes on the subroutine, but it's up to you to get it to do that. You have to have kept track of what attributes are on that subroutine and then pass them back. Ooh, an example. Let's run that. Okay, here, we're declaring this attributes variable, and that's to hold our list of attributes. As I said, we have to keep track of that ourselves. This is our modify code attributes. This is going to happen at compile time, and all we're going to do in this case is add to that list every attribute that was on that subroutine. There's our fetch code attributes. All we're going to do is return the list of all the code attributes that were on that subroutine. As I said, you can do anything inside these methods, but all we did here was keep track of what the attributes were. And so here's an example. I declared a subroutine called cat. I gave it these three attributes. Declared a subroutine called dog. Gave it these three attributes. And now I'm going to run the get method and find out what attributes were on those two methods. Let's run that. And sure enough, down here in the corner, you can see that cat, calico, female, underfoot, dog, collie, female, like squirrels. Not real impressive so far. That's kind of fun, but what are you going to be able to do with that? That was the wrong button. You could probably imagine a whole bunch of things you could do with that, but it's going to be a lot of work. You're really going to have to understand the Perl internals pretty well. So it's time to get clever. The problem with getting clever is that this reason here. So what we're going to do is we're going to steal from somebody even cleverer than us. We're going to use the attribute handlers module. The attribute handlers module is written by, I believe, Damian Conway. He's definitely cleverer than me. It simplifies the creation of the attributes and allows you to define these attribute handler subroutines. We don't have to debug his code. We have to debug our code. That's going to be fun enough. Here's an example using the attribute handler module. we're declaring, this is going to be an attribute handler called foo, and this is how we declare that it is an subroutine attribute. Give it attribute code, and this is what it's going to do. Later, we're defining another subroutine. We're going to give it the attribute of foo, and we're going to have it do something. Now when we run that, pretty clear what that's going to do. It should print foo and then doing useful things. Hopefully I'm right. Indeed, foo doing useful things. Any questions so far? No. Question is, when did foo actually run? Let's look at another example that will answer that question. Okay, in this case, same thing. We've declared the foo attribute. We've declared our do something useful subroutine, and we've declared another do something useful subroutine, do something else useful, and both of them have the foo attribute. Now we're going to call do something useful once, and we're going to call do something else useful twice. What do you figure it's going to print? What's that?
Print foo 3 times and then
Wrong. Wrong. Let's see what it does. It's going to print foo twice. And the reason is this happens at compile time. And we only declared the subroutines twice, or once each. So foo is going to be called twice, and then even if you never ran these down here, never used the subroutines, foo would still be called twice. And then, of course, calling them down here doesn't do anything with foo. It just prints whatever it is that those subroutines are going to print. I said that foo, and this or subroutine attributes in general are going to run at the beginning and during compile time. With this module, you actually can tell where you want it to run. Here I've made a minor modification, and I have it running not at compile time, but at the end and during the end block. So if I were to go back to my code over here, I'm going to tell it to run at the end. Now if I run it, sure enough, it runs the subroutines, and then later it actually runs the attribute handler. You can actually get it to do both.
How are the subroutines running? Because I thought you said it requires foo if it is able to run.
They're running because basically we told them to. They don't require foo. They happen to have the foo subroutine handler. And all what's going to happen here is that when these subroutines are declared, this subroutine up here is going to run at compile time, or in this case at end time. Now, even if we just took these foos off and ran these, it would still run the subroutines, of course. Right. So, now the subroutine handler is itself a subroutine. The attribute handler is a subroutine. Therefore, using this module, you can pass it parameters. And in this case, we've declared a attribute bar and a subroutine do stuff, and it has the attribute bar, and we're going to pass it these 3 parameters. I'll get to in a minute what we're going to do with that. I just wanted to point out that it's possible. Now, what the handler sees when it runs, there's a whole bunch of parameters that are passed. I don't have them memorized, so I'm going to have to look it on my list. What we're getting here is the name of the package. Oops. Name of the package, a reference to the symbol table entry containing the subroutine, a reference to the code in the subroutine, the name, that's the name of the attribute, data, in this case, by default, it's an array reference of all the parameters that were passed to the attribute handler. The phase, now the phase is, I mentioned that it runs at compile time. Actually, it runs during the check block. So by default, this is going to be check. You could get it to run at the begin block, as I demonstrated earlier. You could get it to run at the end block. You can actually get it to run at all of them if you really wanted to. And this is how you differentiate which phase you're in. And then the file that was actually running and the line number of that file that made the call. As an example, all we're going to do here is declare a attribute handler, and what it's going to do is dump its parameters. And here's a subroutine that's using that attribute handler. We're not actually going to call the subroutine. We're just going to let the handler do something here. And unless I really screw up. There we go. And there we go. We've got the name of the package. We got the reference in the symbol table, the code reference, the name of the handler, the parameters that were passed, the phase, the file, and the line number. It's actually starting to work into something that can be used. Okay. Now, why do you want to do something with this? Hold on here. It's all really complicated. It doesn't seem to be doing you a lot of good. So what can you use this for? Here's an example. You want to be told when a subroutine is entered and exited. How you might do that is at the top of your subroutine you might put a little print statement, and at the bottom you might put another print statement. But you don't want to have to do that. The reason you don't want to have to do that is it's error prone. There might be several exit locations, and you're likely to miss one. You're also likely to forget to take them out, check them into Git, and get laughed at during a code review. So you want to avoid doing that. What we will do, the important thing about this, the interesting thing that you can do here, is that inside the subroutine handler, the attribute handler, you can rewrite the subroutine that's being handled. And that's what we're going to do here. Our attribute is called sayWhen. That is a code handler. We're going to grab the name of the full name of the package, or full name of the subroutine, I mean. And then we're using the symbol table because we have a reference to it. We are going to rewrite that subroutine to print the name of the subroutine and the fact that we entered, run the actual code that was in the subroutine and return its values, print the fact that we exited the subroutine, and then return the values that were given. So the effect of all this, of any subroutine that has the sayWhen attribute, is going to print the fact that it was entered and exited. But
I can rerun the subroutine, it inserts a new subroutine in between.
right, when this runs, remember this runs at compile time. This doesn't actually run the subroutine, it's just rewriting the subroutine. So when it's run later, however many times, it's going to run this instead of the original subroutine. Now you could in fact ignore the original subroutine and get it to do something completely different. But in this case, we're going to just bracket the fact that we're running the subroutine with the name of the subroutine that we entered and exited. But wait, there's more. We are going, I said you could pass a parameter into a attribute handler. This is the same code, except now, looking at the parameters that were passed, we're going to pass a prefix that we're going to put in front of the print statements here. And that prefix is going to default to one of these cool little things, greater than sign, but we could pass in something else if we preferred. That's really the only difference in this code. As an example, there's the code we just looked at for the say when attribute handler. Here's a subroutine foo that has that attribute, and a subroutine bar that also has that attribute, but which passes in a different prefix. And then we're down here, we're going to call foo and bar. Notice that bar also calls foo. So when we run this, we're going to get the fact that we're entering foo. Foo does what foo does, and we're exiting foo. That's from running it here. Then we ran bar. There's our different prefix. There's the fact that we entered it. There's the fact that we entered foo again. Foo does what foo does. Foo exit. Bar does what bar does, and bar exits. So any subroutine that you put that say when attribute on is going to do that.
The foo has savory.
Foo.
That's, on line 27, see where flavor is, it's past the
Yep.
savory is past the bar.
Okay, what else can you use this for? Logging, as we just demonstrated. You can get more complex there. You don't have to just print to the screen, of course. You could do some cool logging, write to files, do all kinds of interesting things. Registration. I used this previously to mark certain subroutines that I wanted to be legal to run in certain cases. And so only subroutines that actually it was a customer who was able to pass in a subroutine by name. And because I didn't want to be able to run any subroutine in the class, any method in the class, I wanted to limit it. So only ones with a certain attribute were allowed to be run that way. Asserting test counts. You've probably all used the test class module where you use a subroutine attribute, :test, and then give it a number of tests. And that's how you specify the number of tests that are going to be run in that subroutine. That, of course, is done, that is a subroutine attribute handler. And then wrapping methods and database transactions. This one's my favorite, and this one's I'll demonstrate here. The problem is, well, here's what the code's going to look like when I get done. I have this uses test class. There's an example of the test class attribute handler. This is a test. There's going to be 10 tests in here. I didn't print them all in. And I want to give it an attribute handler called DB. And what that's going to do for me is it's going to wrap this entire subroutine in a database transaction so that everything that happens inside that subroutine will get rolled back when it gets done. The other thing I want to do is pass it a list of things that I need. In this case, I need a test account. I'm starting with a blank database. To run my test, I need there to be a test account. Therefore, I want this to be created inside this database transaction. I want to do it all with the attribute handler. So, let's look at that. This is long enough I have to scroll. Okay, not actually doing all the work, I'm just doing print statements. But here's my routine that's going to create a test account. Here's another one that's going to create a test server. This routine here is just going to, being passed a block of code, it's going to wrap that code in a database transaction, or in this case, say that I'm going to. This is the actual subroutine or attribute handler right here. Scroll that up. It's really very, very similar to what I did with the logging thing. Same thing in principle. All I'm doing is getting my list of needs that I passed in. And for each of those, I am running If I ask for a test account, I'm running create test account. If I ask for a test server, I'm running create test server. Now, you notice that what I'm doing here is I'm just pushing those references to those subroutines onto a list. I'm not running them yet. What I'm going to do then is I'm going to create a new subroutine that I'm going to run. And inside that subroutine, I'm going to go create another subroutine, actually, that runs my list of needs. Create test account or create test server if I said that I needed those things. And then I'm going to run call the original code. Then I'm going to, now that I've created a subroutine that does that, then I'm going to execute that whole thing with the execute in transaction, which will run the entire thing inside of a transaction. This is what I've rewritten the subroutine to do. So what's going to happen, the effect of it is going to be, it's going to run all the needs that I want, and then it's going to execute the subroutine inside of the database transaction. As an example, subroutine test 0 does not have the subroutine attribute. So it's not going to wrap anything in a transaction. This one does. It will wrap this in the database transaction. This one does and wants a test server. This one does and wants a test server and a test account. And I'm going to run all those with various parameters. And we'll see what it does. As predicted, the first one does not in a database transaction. The first one does, or the second one is in a database transaction and it's called with its original parameters. Third one is also going to be in a database transaction, but we're going to call the create test server and then run the routine, original routine with its original parameters, and so on. Down here we're creating the test server and test account first. And then at the end of each of those, we're going to roll back the database. Any questions? This actually turned out to be a real useful thing to be able to do. This is a much more simplified version of the code than we actually used, but it worked out really well. Okay. There's one other thing I wanted to talk about, and that's a different module, SubAttribute. SubAttribute is like a simplified version of the attribute handler. It only deals with code attributes, which is all I've talked about here anyway, but you couldn't do variable attributes with this one if you wanted to. It only processes the attributes at compile time, passes the parameters to the attribute as a single string, which confused the heck out of me at first because, you know, we got an array ref in an attribute handler. Here you're going to get a string. The reason to use it is not because the code that you write is easier to understand. The documentation is easier to understand. The other one is fairly involved. This one is real simple. It only does one thing. And last example I have is the database example again. You scroll down here and go to the attribute handler, because that's the only thing that's different. This is slightly different up here. How you declare the thing as being an attribute handler. Instead of we use attr code, and this is attr underscore sub. The only other thing that's different is now we're going to get, if I said needs and then pass it the list, I'm going to get the string of exactly what I passed, and I have to parse that. Here I'm going to eval it so that I get my, it breaks up my parameters into what I had in the last time. And everything else is the same. No differences. It's just a different way of doing the same thing. I'd run it again, but it would give exactly the same results. And would be even more boring than the first time. Okay. That's it. Anybody have any questions?
How would you do conditionals? Like, you have a
this attribute, or you just take it out? Because you haven't really solved the problem of, oh, I put print statements in there, and now I gotta take them out.
Yeah, I haven't really solved it. It's just simpler to take
But
out.
Is there something that allows you to do conditional?
Nothing specific, but it would.
Write an attribute that was conditional?
Yeah, you just write an attribute. You just stick that in because it's entirely up to you what you put in your attribute. You could have some. I don't.
That's a configuration plan or something.
You could have some global variable that says print or don't print. And
Yeah, I
then,
figured that, I just didn't know if there was anything.
no, nothing built into this. This is a pretty low level thing. You got to do it all yourself. Any other questions? Well, thank you very much then. I hope you had as much fun as I did.